Alright, so chapter 13 is all about sequences and series. So in this first part of this lesson, we are going to learn about sequences. So this is going to be the first video, and there will be one more video to watch after this, talking about specific types of sequences. So first, what is a sequence? Well, a sequence is a list of numbers. That's as simple as it is. It's just a list of numbers. An example of a sequence would be 2, 4, 6, 8, 10, 12, and so on. Well, in that, we can talk about terms. Now, you may realize a pattern here. Most sequences have a pattern to them. What is a term? Well, a term is each number in a sequence is a term. So every number, 8 is a term, 2 is a term, 4 is a term. Well, it's identified by its place in the sequence. So 4 is the second term because it's second in the sequence. 8 is 1, 2, 3, 4, the fourth term in the sequence. 12, it's the last term, but 4, 5, 6, it's really the sixth term in the sequence. There are two types of sequences we're going to focus on here. We're going to talk about finite sequences, so a sequence whose domain, which is the inputs, or x's usually, is specific set of positive integers. So an example of one of these is an, or a sub n, equals 5n minus 6. Well, what is that a sub n that I just mentioned? A sub n is read a sub n, and that's an output value. Or we can consider that the y's. Well, why is this sequence finite? It's finite because it only has or applies to n equals 1, 2, 3, all the way to 8. Now, I forgot to give you some restrictions here. 1 greater than or equal to n greater than or equal to 8. So a finite sequence always has restrictions. Alright? Or basically has a start and an end point. So let's talk about n. N has multiple meanings. 1, it can be the domain. So n can mean from 1 to 8, it's the domain. In terms of a sub n equals 5n minus 6, it tells us, or it's the variable that is substituted in for. So that's what we're actually substituting in for. Well, also, it tells us which term we are talking about. So, if I wanted to substitute in 2, then I'm substituting 2. Well, that tells us that it's the second term. So this means that we have the second term. So a sub 2 equals 4. 4 is the second term. Alright? Well, that about does it for finite, but what about infinite? Well, it's pretty much just what it means. a sequence whose domain is all positive integers. So basically it means it never ends. So it's never ending. An example of this would just be if I only gave you an equals 3n squared plus 2. There's no restrictions, so it's infinite. So no restrictions. So it's infinite. No restrictions. And also, one way that we can see what an infinite sequence looks like, here's another example. If I give you a list, like 1, 2, 3, 4, this dot, dot, dot here tells me infinite. It doesn't end. Alright, so let's move on to actually working with some of these sequences. So finding terms in a sequence. First, you're going to identify the input values. So for this sequence over here, what that means is I'm identifying my input values, 1 through 4. So I know I want A1, I want A2, I want A3, and I want A4. Alright, next, after identifying that, we're going to substitute each value into given formula. So I was given the formula here, so now let's substitute. 5n is 1 plus 1. 5n is 2 plus 1. 5 times n is 3 plus 1. 5 times n is 4 plus 1. Next, once I've substituted, I'm going to simplify. So simplifying, 5 times 1 is 5 plus 1 is 6. 5, that's 10 plus 1 is 11. 15 plus 1 is 16. 20 plus 1 is 21. And no, you're not done, because the last thing is to answer with a list. Remember, sequences are lists, so we need to put these in order. So 6, 11, 16, 21. That's my list for this given equation. Alright, so let's keep going. 1. Identify input values. So C1 all the way to 5. C2, C3, C4, and C5. Substitute in -2 to the first power, -2 squared, -2 cubed, -2 to the fourth, -2 to the fifth. Simplify. Well, -2 to the first power is just -2. -2 squared is like -2 times -2, which gives you a positive 4. -2 cubed stays negative. -2 to the fourth power becomes positive, and fifth power becomes negative. Now notice this is alternating. We're actually going to go over that in a little bit, but right now we're just going to notice that each term alternates. So I need a list here: -2, 4, -8, 16, -32. And that's my list. Alright, I'm going to do one more with you, and then these last two are going to be for you to try. So B1, B2, B3, B4, B5, and I'm going all the way to B6 here. This one gets a little bit tricky. So I have n to the 1/2, n is 1 to the 1/2 power, 3 to the 1. Alright, now I'm on 2, so 2 to the power 1/2, 3 squared. Now I've got 3 to the 1/2 power, 3 to the third, 4 to the 1/2 power, 3 to the 4th, 5 to the 1/2 power, 3 to the 5th, and 6 to the 1/2 power, 3 to the 6th. So again, this is where it gets a little bit tricky. Remember that 1/2 is the same thing as the square root as a power. So I really have the square root of 1 times 3. Well, that's really 3. Here I have the square root of 2 times 9, so that's 9 square root 2. Here I've got square root of 3 times 3 cubed, which is 27. So I have 27 square root 3. Here's where it gets a little bit more complicated. Square root 2, square root 4 times 81. Well, this is really 2. 2 times 81 is 162. Alright, keep moving. Square root of 5 times 243, that's 3 to the 5th. 243 root 5. And root 6 times 729. If you keep doing that in your calculator, you'll need some assistance there. 729 root 6. Finally, my list. 3, 9 root 2, 27 square root 3, 162, 243 root 5, and let me squeeze 729 root 6 in there. Ran out of a little bit of space, but it's there. Alright, again, these two here are for you to try. Your directions are to list the first 4 terms. So it should be fairly easy. Just work it out, simplify, use your calculator if necessary. And then after that, make sure you watch the next video describing how to find a sequence.